Welcome to MathCat. Today we're going to be talking about multiplication, and we're going to be introducing the concept of an equation. This is a term you'll see on homework and tests, and you should be familiar with what the concept means. So an equation is an expression that shows that two things are equal, even if they look different. So both sides of the equal sign represent the same quantity. So here we have a jar of 4 blue objects, and we have 2 of those, so we can add 4 plus 4, and we get a total of 8 objects. So we have just written an equation to represent adding the total number of objects, and both sides equal the same value. So we have 2 jars of 4 objects, and if you combine those into a single jar, you have a jar of 8 objects. And that's all an equation is. It just is saying that the left side of the equal sign is the same thing as the right side of the equal sign. They're the same value. They equal the same value, even though they might look different. You can express 8 as 4 plus 4, like in this example that we just did. Now we could also have multiplication as our equation. We have 4 objects in each jar, and we have 2 of those jars, and that also equals 8. So now we have an equation. On one side, we've represented 8 as 4 multiplied by 2, whereas before we had 4 plus 4, but they both represent 8. Now the numbers being multiplied together are each called factors. So 4 is a factor, 2 is a factor, and the value you get when you multiply them together is called a product. And the symbol for multiplication can also be expressed in different ways. So here you have 4, and the multiplication is an X. And it can also be a star, and it can also be a dot. And those mean the same thing. Those all mean 4 times 2. Now let's talk about equations with groups. So let's say you have 3 groups, 1, 2, 3. And in each group, you have 4 objects. Okay. Now, an equation for this would be you have 3 groups, and you have 4 in each group. And a lot of times you'll see the number of objects in each group, the group size, circled. And that's just to keep track of how many groups you have versus how many objects in each group. So you can read this as you have 3 groups of 4 objects. And that becomes a multiplication problem. You can also think of this as doing 4 plus 4 plus 4, which equals 12. Let's do a couple more problems like this. 3 times 5 equals 5 plus 5 plus 5 equals 15. And you can circle the number of the items in the group. And we know that 3 times 5, we have 3 groups of 5. So we have one group of 5 plus another group of 5 plus another group of 5. And if we add that together, we get 15. Another example would be 6 times 5. So we have 6 groups of 5, and that equals 5 plus 5 plus 5 plus 5 plus 5 plus 5. And if we add up all those 5s, we get 30. So again, just conceptually, we have 6 groups of 5. So we have one group of 5, 2, 3, 4, 5, 6 groups of 5, and we add that together and we get 30. Now, another type of problem you might see is just a picture. So you might have a picture like this. And the question in the problem just says, write an equation for the picture. So what you do now is you look at how many groups you have. So you have 1, 2, 3, 4 groups. And you know you're going to do multiplication. And you have 3 in each group. So circle the size of the group. And you know that you have 4 groups of 3. So 3 plus 3 plus 3 plus 3. And that equals 12. So that's how you would solve a problem like that, if that was the directions. So there's a huge variety that you will see with these types of problems. It could present as really any kind of picture, and the instructions would say write a multiplication equation to find the total number. So it could just say how many fingers. And if you just were to say 20, let's say you just wrote 20, you're probably going to get that either wrong or some points taken off, because what they really want is they want you to write an equation for this to solve this problem, not just writing the answer. So they want to see that you understand the concept of an equation and what you're really doing here to find the total number. So they want you to understand that this is a multiplication problem, and they want to see that you understand the concept of a group and the number of objects in a group, and that means you need to multiply. So you have 4 groups. So you have 4 groups of 5, and that equals 20. And not all teachers will require you to show the addition to, but if they do, that's 4 times 5 equals 5 plus 5 plus 5 plus 5, like we did before, and that equals 20. So some teachers might want to see that you understand that 4 groups of 5 is 5 plus 5 plus 5 plus 5, but not all teachers are going to want to see that. But just in case they do, that's what that looks like. And you might also see a problem where it just says how many legs, and it shows a picture like that. Well, you do the exact same logic. So you say, well, I have 4 groups. So you always start by writing the number of groups you have. And I know it's going to be multiplication. And how many legs are in each group? I have 4 on each dog. So that's how many objects are in each group. And that equals 16. So that would be the answer for that question. So you might come across these kinds of problems that just say, describe ways to solve, and then some kind of multiplication problem. So like 7 times 5. And that just means that they want you to describe several ways that you can think of to solve 7 times 5. So one way would be what's called skip counting. And that means counting by 5s 7 times. So you'd have 5, 10, 15, 20, 25, 30, 35. So you counted by 5 7 times. So that's 7 times 5 equals 35. You could also draw tally marks if you wanted to, but typically you would just write out the steps by 5, like 5, 10, 15, on and on until 35. The second way is equal groups. And this is almost like coming up with your own little word problem to solve this. So you could say, imagine you have 7 plates and each plate has 5 apples. How many apples are in total? So you could say, I have groups of 5 apples. So 1, 2, 3, 4, 5. And I have 7 of those groups. 2, 3, 4, 5. I need one more. So that's 7 groups of 5, and you could just add those up. So the total, 35 apples, or whatever example you want to come up with. The third way, you could say turn it around, which is also called in math the commutative property. And all that means, that's a fancy word in mathematics, that just means you can flip the order of addition or multiplication and it's the same exact thing. It's the same exact answer. So 7 times 5 equals 5 times 7. And you could do the skip counting here, but with 7s this time. So you would do 7, 14, 21, 28, 35. So we did the same thing, except here we had 7 groups of 5 above, and now we're doing 5 groups of 7. So we have 1, 2, 3, 4, 5 groups, and each group has 7. So your total is 35. The fourth way is use facts you know. So if you know 5 times, let's say you just I can't think of what 7 times 5 is, but I know what 5 times 5 is. That's 25. So remember, we have 7 groups of 5. And we know what 5 of those groups is. That's 25. So I need 2 more groups. 25 plus 5 plus 5. I need 2 more groups of 5. Well, that's 25 plus 10, which is 35. So does that make sense? Let's say you're just like, oh, I can't think of what 7 times 5 is, but I know 5 times 5 is 25. So that's 5 groups, and I need 7 groups. So then you just add 2 more groups. So you take 25, which is 5 plus 5 plus 5 plus 5 plus 5. That's your 5 groups. Plus 2 more groups is 7 5s. So that's 25 plus 10, which is 35. So here's a summary of the ways we discussed for finding 7 times 5. Skip counting, equal groups, turning it around, and using facts you know. Feel free to take a screenshot of this so you can reference it later or practice other problems like this. Next, let's talk about how to solve word problems for multiplication with equal groups. What you want to remember with these problems is you want to pull out the information that you need to form an equation like we did in the previous problem. So let's look at an example. Liam picked 5 baskets of apples. Each basket has 5 apples. How many apples did he pick in all? So what you want to do is say, okay, I need to form an equation like this times this equals, and that's what you're trying to solve for. So remember, we start with the number of groups. So we have 5 baskets. In this case, a basket is our group. And we know we're going to multiply. And then we multiply it by how many objects in that group. So we have each basket has 5 apples. So we're going to multiply that by 5. And that equals 25. And one of the keys in these kinds of problems is showing your work. So if you just put 25, you're probably going to get that wrong. And then you might be like, it's the right answer. Why did I get that wrong? Well, it's because they want to see your work. So they want to see an equation written out like this, showing that you understand what's the group and what's the objects in the group. So now let's look at another example. And you'll notice like all these problems are really similar. It's just the number of groups and the number of objects in the group changes. But you want to think about them in the same way. Diego built 3 shelves. Each shelf has 7 books. How many books were on the shelf in all? So again, you're going to say, how many groups do I have? I have 3, and I know it's going to be multiplication. And then how many objects are in each group? Well, we have 7 books on each shelf, which is our group. And that equals 21. And again, some teachers want you to show that you understand that the multiplication is addition of all the elements in the groups. So you could, if they require that, you would say 3 times 7 equals 7 plus 7 plus 7, which equals 21. So you get the same thing. It's just another step that some teachers might want you to show. Another type of equal groups problem that you'll come across is one where the directions ask you to draw an equal groups diagram, or sometimes called an equal shares diagram. And it's the same kind of problem that we were doing before, but this time you're just going to draw a different type of diagram to show your understanding of multiplication and division as equal groups. And so what that will look like is you go about it solving it the same way we did before. So for this problem, Eva baked 5 trays of cookies. Each tray had 6 cookies. How many cookies did she bake in total? So you're going to start the same way we did in the previous problem. So you have 5 groups, and each group has 6 cookies, and that equals 30. Now for the equal shares diagram or equal groups diagram, you're going to show that 30 can be broken down into 5 groups of 6. 2, 3, 4, 5. So there's 6 elements in your group, and you have 5 of these. So this would be your equal shares or equal groups diagram. And what this is showing is that you see what's happening. So you have 5 groups of 6 versus 6 groups of 5. So it's not just a different set of numbers, but it's also a different visual structure. So this really shows that you understand the number of groups and then the group size. And if the problem was switched, where it was like you had 6 trays of cookies and each tray had 5 cookies, then this diagram would be switched as well. And that shows your understanding of groups versus objects in a group. It also helps you understand that multiplication is repeated addition. It helps you see that division is splitting into equal parts. So we're starting to look at multiplication of a number, of two numbers being the same thing as dividing it into groups. And it also can help different learning styles. Some people are a little more visual and benefit from seeing the groups versus just writing it out like we did here. Some people, that's an easier method, so it's just another way of visualizing it. And it also helps prepare you for more complex thinking. So later on, you'll start breaking numbers into partial products or remainders, and visuals kind of set you up for that. It also is a good way of error checking. So sometimes it's easy to misread word problems, and drawing helps catch whether you really understand the number of groups versus how many in a group, like I said before. So in short, the drawing isn't a way just to get the answer. It's a way to build meaning, develop conceptual understanding, and ensure that you aren't just memorizing facts like 5 times 6 is 30. That's great that you memorize that, but do you really understand what multiplication and division represent? So that's the whole reason you might see a problem like this where it's like, solve this by showing an equal shares drawing. So I just wanted to show an example of that because that might come up in homework and tests.